Okay, we know that hurricanes are big storms, and just like the smaller storms, they have to do with rising hot air. Now, before we get out there, let's talk about how rising hot air makes storms. One way is having these cold fronts pushing into warmer air. As the cold front moves forward, we've been over this in another video, but as a cold front moves forward, it takes this hot air here and sends it up. And with all that hot air going up, it forms cloud upon cloud upon cloud, and you have these huge clouds that go way up into the upper reaches of where clouds can even be. And these huge clouds end up having the ice at the top, which ends up falling and forming these thunderstorms. So that's one way you get a lot of rising hot air, but it's not the only way. Another way you get a lot of rising hot air is just in normal summertime. I'm sure you've experienced it where you have a really hot day, and then oftentimes in the summer afternoon you'll have a storm. And all that is you're just getting so much heat in these July and August days that with all this heat you're going to have what turns out to be a whole lot of air rising. And the same thing is going to be true in tropical areas. Areas like Brazil, some of us are studying in social studies, get a lot of heat, and you get a lot of hot air rising, forms all the clouds, and as the clouds are forming, you're going to have a good chance of having some storms. And you know, we have afternoon thunderstorms all the time in the summer. So those are two ways on land that you get hot air rising and forming storms. Now, hurricanes are bigger than afternoon summer storms, and they're bigger than cold fronts. Now, cold fronts can really have a big impact on us, but still hurricanes can be hundreds of miles wide. Let's talk more about the hurricanes itself. The hurricanes happen over the ocean, of course, but the water over the ocean has to be very hot. In fact, I have it right here that the water has to be about 80 degrees or higher. Now, you may remember that it's easier to get 80 degrees. Land gets hotter quicker than water does. So you can get to 80 degrees on land sometime in the spring. But it takes late in the summer before this ocean can get 80 degrees. And it's only going to get 80 degrees out in equator type areas. It's not going to get 80 degrees way up here. It's not going to get 80 degrees way up here. It's not going to get 80 degrees way up here, or not going to get 80 degrees way down there. But it's going to be in these tropical areas near the equator where the trade winds are. These are the areas where it can get to 80 degrees, and as a result, these are the areas where hurricanes form. They're not going to form until it gets to be 80 degrees or so. So most of these hurricanes form late in the summer. We're talking like August on through October. The water has to be very hot. It's going to be late summer. It's going to be near the equator. On land, hot air rising makes brief storms, an hour at most. Over the sea, however, hot air rising brings lots of evaporation. So if you have a storm on land, there's only so much water that you have with it. You may have an hour-long storm and it's going to die out at some point. Every once in a while you'll have days and days of rain, but generally you're not going to get as much water evaporation over land as you are over the sea. So when you have some kind of storm in the ocean, here's my pitiful little drawing of a hurricane here. When you have some kind of storm in the ocean, you have a constant source of evaporation. All this hot water just keeps evaporating water into it. So it can start raining here and can end up raining for a few thousand miles before it runs inland and dies out. You really have a lot of fuel, you might say, to these storms. So they tend to be much bigger, these storms over the ocean, and they're continually fueled with all that water as long as it's over the ocean. Now these storms spin because of the Coriolis effect. Here we have what looks like a hurricane. This is a pretty bad looking hurricane right here. And it is spinning. Now the reason it's spinning is because the Earth is actually turning that way. So as the Earth is turning that way, you've got this mass of a storm that is actually in the air above the Earth. So as a result, while the Earth spins that way, storms move this way. And I think it may be better seen on this map back here. The Earth spins this direction. Earth spins this direction. So if you have some kind of storm that is above the Earth in the atmosphere, then it has a tendency to kind of spin out. And that's exactly the kind of path that hurricanes take that affect us, because the Earth underneath it is moving that way, and it tends to spin whatever is in the atmosphere above it. It's the Coriolis effect. We've studied it before. Now, these storms, if they are a tropical storm, they will look like this. This is not as well defined. You can see that it does have the spinning action, coming around this way, coming around that way, but it's not as well defined. As a result, a tropical storm, by definition, will have winds 40 miles an hour and up. If it's below 40 miles an hour, it's not a tropical storm. Hurricanes on this side, however, have winds 74 miles an hour and up. And some of them can really get to be way up above 74 miles an hour. Mention about the Coriolis effect. The eye of the storm, I think all of you know what the eye of the storm is. The eye of a hurricane is this area right out in here. The eye of a hurricane, and sure enough, I'm trying to find it on my notes right here. Well, I can't find it, so I'll just start reading where I think I left off. These hurricanes are low pressure systems and can even become tropical storms or hurricanes. Hurricanes are called typhoons in other places of the world. And the places of the world that they are called typhoons would be in the Far East. The Far East. It probably wouldn't have hurricanes way up in here, but in the Far East is where you have hurricanes, and they're called typhoons there. Hurricanes spin because of the Coriolis effect. They travel west, and the reason they travel west is because of the trade winds. You may remember that all of these are forming near the equator. So you have the equator that's down about here. They're all forming in this vicinity here, or at least the ones that affect us. And what happens is you have these trade winds that are down in this vicinity. So that's one of the reasons why it spins and goes this direction, because they get caught up in the trade winds. Let's see what else we have here. Ooh, I'm kind of getting a pickle here because I'm losing where I am in my notes. But anyway, I'll find it here in just a second. Oh yeah, once the hurricane hits land, it then goes in different directions. They all travel in this direction. They all travel west on water. But then once they hit land, that's when they can go up, they can go down, they can go even back to the right, or back to the, did I say east? They travel to the west in the beginning, and then once they hit land, they can go, they're unpredictable, and can even go back toward the east from where they came from. And it's just kind of unpredictable when it does happen to happen that way. The center of a hurricane, which I mentioned earlier, is called the eye. It is 10 to 30 miles in diameter. 10 to 30 miles in diameter. And it's called the eye. Hurricanes hitting land have strong wind and heavy rains. They can lift cars, uproot trees, tear off the roofs of buildings, spawn tornadoes within hurricanes, and produce flooding. Most hurricanes move toward land and it pushes a huge mass of coastal water known as the storm surge. Now we'll mention storm surge in just a second, but I want to show you some effects of tornadoes. Not tornadoes, but effects of hurricanes. Here's some pictures I pulled off the internet. You can see the sources underneath them, the flooding, the winds that apparently damaged this building right here, how these ships were pushed up against the bridge there, and you can see how the wind and the water just really damaged this area here. Here's some other storms. This storm is Sandy. This storm was this last year from when I'm making this video, up along the eastern coast. This storm is Katrina, maybe most famous hurricane we've had in the south here. And this storm right here I think is also Sandy, the one more recent. Look at this highway. This is a highway right here. And the storms and the water has just blown and brought all kinds of stuff up through here. And look at this highway. I mean, this highway was stopped. This bridge was stopped right there, and you got emergency vehicles to keep people from trying to make it there. Here's a boat trying to come help right there. Okay, let's talk about storm surge. Here we have the hurricane, and we have what's called a storm surge. I'll remind you what it says. When a hurricane moves toward land, it pushes a huge mass of water known as the storm surge. So here's the normal tide, or here's the normal amount of water, and you've got this storm surge. This storm surge, as the hurricane is going in whatever direction, it kind of just builds up water and builds up water and builds up water. It's kind of like it's pushing it. It's pushing water, kind of like pushing something out from under a rug. And here's some better video of it. Here's the normal, not video, but here's better pictures of it. Here's the normal tide, and this storm surge, about 15 feet of water. So whenever you have a hurricane coming in, you don't have these tsunami type waves. I mean, you'll have waves a couple of feet high, but still they're so high because of the storm surge. Here's another one. You have normal sea level, which comes in down here. Then you have the storm surge, which is even higher right here. And just the storm surge itself can have a lot of flooding, and then you have these waves 2, 3, 4 feet like that happen to come down upon that as well.